Welcome to Omni Eyes. Today we explore the incredible stick insect, a true master of camouflage and advanced motion detection. Look closely at this branch. What seems like ordinary wood is actually a living creature, perfectly hidden in plain sight. The stick insect is virtually invisible to predators, utilizing extreme camouflage to survive in a highly dangerous and unforgiving environment. When the gentle breeze rustles the forest leaves, this clever insect sways rhythmically along, perfectly mimicking the natural environmental motion. This biological marvel perfectly balances the art of complete concealment with the critical need for constant and vigilant environmental surveillance. In episode 47, we analyze this fascinating balance between hiding and watching, drawing striking parallels to modern security technology. Despite remaining completely motionless to avoid detection, the stick insect possesses incredibly sharp and highly optimized vision for survival purposes. Its unique compound eyes are biologically engineered to detect even the absolute smallest movements from potential predators approaching from afar. While the surrounding leaves shake violently in the wind, the insect maintains absolute focus on the true and immediate threat. This creature has an extraordinary biological ability to completely ignore environmental noise, focusing only on movements that indicate clear danger. Imagine a modern surveillance camera placed directly in a highly complex outdoor environment, filled with constantly moving trees and bushes. Traditional motion detection algorithms often trigger countless false alarms whenever the wind blows and the surrounding vegetation begins to sway. A sudden gust of wind can easily confuse a standard camera system, flooding your notification center with completely useless alerts. However, the remarkable stick insect solves this complex visual problem effortlessly through millions of years of rigorous and brilliant evolution. Let us dive deep into the micro world to understand exactly how this fascinating biological motion detection system actually works. The eyes of the stick insect are composed of thousands of tiny individual lenses called ommatidia, forming a complex network. Each tiny lens captures a tiny fraction of the overall visual field, creating a highly detailed mosaic of the surroundings. This multifaceted visual system allows the insect to monitor a very wide area without ever needing to move its head. Moving the head would instantly break its perfect camouflage, revealing its hidden location to hungry predators lurking in the canopy. Therefore, the creature relies entirely on its specialized neural pathways to process visual information, while remaining completely and perfectly still. When a leaf sways in the wind, it creates a very specific, predictable visual pattern across the insect's compound eyes. The insect's tiny but highly efficient brain quickly recognizes this rhythmic motion as harmless background noise generated by the environment. It effectively filters out this useless visual data, preventing its nervous system from becoming overwhelmed by constant and meaningless stimuli. But when a predator, like a hungry praying mantis, slowly creeps closer, the visual pattern is entirely different and unpredictable. The predator's deliberate and stealthy movements trigger a completely distinct set of neural responses within the insect's tiny visual cortex. This sudden anomaly in the visual field instantly alerts the stick insect to the presence of a very real danger. It is a highly sophisticated biological algorithm designed specifically to distinguish between random environmental fluctuations and intentional, threatening predatory behaviors. Engineers and scientists are now closely studying these magnificent creatures to improve the artificial intelligence inside our modern security cameras. By mimicking the neural processing of the stick insect, developers can create significantly smarter and much more reliable surveillance systems. These advanced cameras will be able to completely ignore swaying branches and falling leaves, focusing only on actual human intruders. This incredible field of study is known as biomimicry, where human innovation draws direct inspiration from nature's most brilliant designs. The stick insect teaches us that effective surveillance does not always require constant movement or overwhelmingly complex and massive hardware. Sometimes the most powerful observation tool is simply the ability to remain perfectly still and filter out the unnecessary noise. Let us observe the stick insect as it navigates a dense forest canopy, constantly scanning for threats while remaining invisible. Notice how its elongated body perfectly mimics the texture, color, and even the tiny imperfections of the surrounding tree branches. Even the joints of its legs are specifically shaped to look exactly like the small nodes and twigs of plants. This extreme level of physical camouflage requires an equally extreme level of visual processing to ensure complete and total survival. If the insect cannot see the approaching danger, its perfect disguise will ultimately fail, resulting in a swift, sudden death. Therefore, the evolution of its camouflage and the evolution of its motion detection capabilities are deeply and inextricably linked together. One cannot exist without the other in the harsh, unforgiving reality of the wild, where every mistake is heavily punished. Watch closely as a large spider slowly approaches the resting stick insect from behind a thick, dark green tropical leaf. The spider moves with extreme caution, attempting to minimize its own visual signature to avoid alarming its potential insect prey. However, the stick insect's multifaceted eyes have already detected the subtle, irregular movement of the spider's legs creeping ever closer. Despite the immediate and terrifying danger, the stick insect remains absolutely frozen, trusting completely in its masterful and perfect disguise. It knows that any sudden movement would instantly betray its position, turning a potential threat into an unavoidable, deadly attack. The spider pauses, confused by the lack of movement, unable to distinguish the insect from the ordinary branches around it. This tense standoff perfectly illustrates the incredible power of combining flawless physical camouflage with highly advanced, motionless visual threat detection. The stick insect wins this silent battle of survival by simply outsmarting the predator's visual system with its own absolute stillness. Eventually, the frustrated spider gives up the hunt and moves away, leaving the invisible master of disguise completely unharmed today. This remarkable survival strategy is a true testament to the endless wonders and highly complex mechanisms of the natural world. Now, let us shift our focus back to the realm of human technology and the challenges of modern video surveillance. Outdoor security cameras face the exact same environmental challenges as the stick insect trying to survive in a windy forest. Shadows moving across the ground, rain falling heavily, and insects flying near the lens can all trigger annoying false alarms. Homeowners and security professionals often grow incredibly frustrated with these constant, meaningless alerts flooding their smartphones and monitoring station screens. To solve this very persistent problem, software engineers are developing artificial intelligence algorithms that function much like the insect's brain. These smart algorithms analyze the specific patterns of movement within the video frame, rather than just detecting simple pixel changes. They are meticulously trained to recognize the rhythmic, repetitive motion of trees swaying in the wind as completely harmless background. Conversely, they learn to identify the distinct, linear, and purposeful movements of a person walking across a dark, quiet yard. By applying these biological principles, we can drastically reduce false alarms and create much more efficient and reliable security networks. The camera becomes a silent, intelligent observer, perfectly hidden in the environment while maintaining a highly vigilant and accurate watch. This is the ultimate goal of modern surveillance technology: to see absolutely everything without ever being seen or easily distracted. The stick insect has already perfected this incredible art over millions of years of slow, deliberate, and highly successful evolution. As we continue to study this fascinating creature, we uncover even more incredible secrets hidden within its tiny, highly complex eyes. For instance, researchers have discovered that the insect's eyes are exceptionally sensitive to changes in light intensity and subtle contrast. This heightened sensitivity allows them to detect movement even in the extremely low light conditions of a dense, dark forest. Imagine a security camera that can clearly identify a creeping intruder in the dead of night without using bright spotlights. By understanding the unique photoreceptor cells in the insect's eyes, scientists hope to develop far more advanced night vision sensors. These new sensors could revolutionize the way we monitor remote and unlit areas, providing unmatched security in total, complete darkness. The potential applications for this exciting biomimetic technology extend far beyond just simple home security cameras and basic monitoring systems. Autonomous vehicles could use similar algorithms to accurately detect pedestrians stepping onto the road amidst a chaotic, highly cluttered background. Military drones could silently observe enemy movements from the sky, easily filtering out the natural motion of the surrounding terrain. Wildlife researchers could deploy smart cameras to monitor endangered species without disturbing their natural habitats with loud, intrusive mechanical noises. The possibilities are truly endless when we look to nature for elegant solutions to our most complex and difficult technological problems. Every single aspect of the stick insect's biology is beautifully optimized for its unique and highly specialized mode of survival. Its nervous system is a marvel of biological engineering, processing vast amounts of visual data with incredible speed and efficiency. Despite having a brain the size of a pinhead, It outperforms many of our most advanced and expensive computer systems. This stark contrast highlights the incredible efficiency of biological computing compared to our current, power-hungry artificial intelligence hardware systems. Nature has spent billions of years refining these biological algorithms, achieving a level of perfection that we currently only dream of. By carefully studying and recreating these highly advanced natural systems, we can leapfrog decades of traditional technological development and research. The stick insect is not just a master of disguise. It is a living, breathing blueprint for the future of technology. Let us take another close look at the insect's remarkable ability to remain perfectly still for hours on end today. This extreme patience is a crucial element of its overall survival strategy, requiring immense muscular control and unparalleled physical endurance. While we humans struggle to sit completely still for even a few minutes, this insect can hold its pose effortlessly. It becomes a permanent, unmoving fixture of the surrounding environment, patiently waiting for danger to pass or night to fall. During this time, its powerful compound eyes never stop working, constantly scanning the horizon for any signs of approaching predators. It is a state of active meditation, where the body is entirely at rest, but the mind remains sharply focused. This perfect harmony between physical stillness and intense mental vigilance is what makes the stick insect such a fascinating subject. It challenges our conventional understanding of what it means to be actively observing and interacting with the complex world around us. We often associate observation with movement, turning our heads and shifting our gaze to take in our highly dynamic surroundings. But the stick insect proves that true awareness can be achieved without ever moving a single muscle in your body. It is a powerful lesson in the importance of quiet observation and the incredible capabilities of highly specialized visual processing. As we continue to develop new technologies, we must remember the elegant and simple solutions already perfected by Mother Nature. The next time you walk through a forest, take a moment to look closely at the seemingly ordinary branches around you. You might just be staring right at a hidden master of disguise, silently watching your every single move with precision. And as you install a new security camera at your home, think about the incredible biology that inspired its software. The delicate balance between camouflage and surveillance is a timeless evolutionary dance that continues to shape life on our planet. From the deepest, darkest jungles to the most advanced modern smart cities, the principles of motion detection remain entirely universal. We are constantly learning from the natural world, adapting its ancient wisdom to solve our modern, highly complex technological challenges. The stick insect, with its motionless body and watchful eyes, stands as a brilliant symbol of this amazing scientific intersection. It reminds us that sometimes the most profound and revolutionary secrets are hidden right in plain sight, waiting to be discovered. Thank you for joining us on this incredible journey into the microscopic world of advanced biological surveillance and natural camouflage. We hope you have gained a new appreciation for the silent, invisible creatures that share this beautiful and complex planet. Nature will always be our greatest teacher, providing endless inspiration for the incredible technologies that shape our modern human lives. Be sure to subscribe to our channel for more fascinating insights into the hidden wonders of science and the natural world. Until next time, keep your eyes wide open and stay curious. This is Omni Eyes, signing off for today's episode.